Hi guys, so we've talked about arithmetic sequences. We've been working on geometric sequences. You guys finished your bunny exploration yesterday, and so you kind of have an idea of what these sequences already are going to be. So let's talk about it. Well, let's just take some notes. Lesson 9-8 is about geometric sequences, and that's what we're going to learn about. So a geometric sequence, kind of like our bunnies, we started out with 2 rabbits, and then each of those rabbits had 2 rabbits. So that made a total of 4 rabbits in the second generation. And then each 4 of those rabbits had 2 rabbits, or each set of those had 2 rabbits. So you ended up with 8 in the third generation. And then all of those had 2 rabbits, so you ended up with 16. And you ended up with 64. Sorry. You ended up with 64 in the next one. No, 32. Shoot. Dang it. Okay, so have you ever gotten a chain mail letter where it says, send this to 10 other people and you'll win $1 million or something like that? And so you send it to 10 other people, and of course, you don't ever win anything. But those 10 people then get it, and they think they're going to win. So they go ahead and send it to 10 other people. So now we started at 10, and then those 10 sent out 10. So we ended up with 100 in the second set. And then if they did it again, we would end up with 1,000 in the next set, and so on and so on. Well, let's do that with 5. So let's say the email says that you are going to send it to 5 people and you win $1 million. So you send it to 5 people, and then they send it to 5 more people, then they send it to 5 more people, and pretty soon we're at 625 just in the 4th generation set. So let's talk about how this equation works for this, or we're going to build an equation for it. Well, we know that A1 is 5. Our first term is 5. We know that. So if we have the first term as 5, I went ahead and split the 25, the 125, and the 625 down into some things. So we can say that 25 is the same thing as 5 squared. Agree? So if that's 5 squared, can we put it as 5 times 5, or 5 to the first power? So then the second set, well, we can say that this is 5 times 5 times 5, or 5 to the third power, right? Well, if that's 5 to the third power, which is 125, then can we split them up and say 5 times 5 squared? This 5 squared is the 25. That's where that came from. And then it multiplied by the original 5. So, and then to do 625, same thing. 625 would be 5 to the 4th power, 5 times 5 times 5 times 5, which is 5 to the 4th power. Well, I can break that down a little bit, and I can take the original 5 and put it here, and I still have the 5 to the 3rd here. Now, why in the world would I want to do this? Well, we're trying to create that equation that's going to work every time. So we know that this 5 right here is our first term. Our first term is 5. It will always be that term right there. Then what's going on here? Well, this 5, it's a little confusing because I used 5, and you're always going to multiply it by that first number, or you might multiply it by something else. Well, this 5 right here is our common ratio. If we were to write this out, 5, 25, 125, 625, and so on, then we're multiplying by 5 each time. This is our ratio. So that's where the second one comes in. This is our common ratio here. Now, the exponents here are a little tricky because this is a 1, but this is term 2. And this is a 2, but this is term 3. And this is a 3, but this is term 4. So each one is always 1 less than the term that we're looking for, the term that it is. So we can say that this is r to the n minus 1 because it's always 1 less than the actual term it is. So let's see if this works. So the next term here would be multiplied by 5 again. So that would be 5, 2, 12, 31. 3,125 should be the next term. So if we come in here and we put 5, our common ratio is still 5 because we're multiplying by 5 each time. And this would have been the 5th term. This would have been the next one in the sequence. So this should be to the 5 minus 1, or to the 4th power. So 5 to the 4th power we know is already 625, right? And if you multiply that 625 times 5, you end up with 3125. So see how that works? So our equation for geometric sequences is a to the nth power equals a1 times the ratio to the n minus 1 power. So that's the equation that we're going to be using. So if I ask you to find the 6th term, the 6th term in this sequence, 1/2, 1/4, 1/8, 1/16, and we're looking for the 6th term. Yeah, we could keep going, but we're trying to practice that equation, so let's do that. So we have a to the nth equals a1 times the common ratio to the n minus 1 power. So our a1 we know is the first term, that's 1/2. Our ratio here is we're multiplying by 1 over 2. Multiply 1 over 2, multiplying by 1 over 2. So again here, and this doesn't always happen, by the way. I just gave you 2 examples that it happened to work that way. It's not going to happen that way all the time. So the common ratio is 1/2, and we're looking for the 6th term, so 6 minus 1. So we're looking, make sure you're following order of operations. Do not multiply these first. That's not right in PEMDAS. PEMDAS says we have to do the exponent first. So this is 1/2 to the 5th power. So we know that 1/2 to the 5th power, well, 1 to the 5th power is still 1. And 2 to the 5th power is 2, 4, 2 times 2 times 2 times 2 times 2. Of course, you can always put this in your calculator. 4 and 2, so 16 and 2 is 32. So our denominator is 32. And we're going to multiply that then by 1/2. So our a to the 6th term is 1 over 64. That would be our 6th term. Okay? One more example, and I want you guys to work through it. So I want you to find the 10th term in this sequence. So remember that the formula is a to the nth equals a1 times the common ratio to the n minus 1 power. So before you do this really quickly, do you remember we had a little purple thing that we put in our iNotebook for the arithmetic sequence, and it kind of, I don't know, it looked weird. It looked like this or something kind of like that. And then you folded these things over. You guys remember this? Well, I gave you a second one. The second one is for this equation, and it goes the same way. It would have been a to the nth equals a1. So this is a box, and this is a box, and this is a box. And then the r is a box. And then there should be a long one on the end, which is the n minus 1 on the end. So make sure that you go ahead and get that finished and put into your iNotebook as well. So back to this, go ahead and pause it. See if you can come up with finding the 10th term, and then come back and we'll check it here in just a minute. Okay, so we know that our common ratio here, we're multiplying by 3. So we're going to start with the first term, which is 4, times the common ratio, which is 3, to the n minus 1. Well, we're looking for the 10th term, so that would be to the 9 minus 1, or to the 8. Now, again, do not multiply this first. That does not follow PEMDAS. Make sure you're doing the exponents first. So we're going to do 3 to the 8th power, and I'm sure you can do this faster in a calculator than I can do it on the board. 2, 3, 4, 5, 6, 7, 8, 9, and 9, which is 81, and 9, and 9, which is 81. So it looks like 81 times 81. So this part right here is 6,561 if my multiplication is correct, and then we're going to multiply that times 4. So it looks like the 10th term in this sequence is going to be 26,244. They get really big or really small really fast. So you're going to have an assignment that you're going to be working on. It's the arithmetic, geometric, or neither maze. You're going to start at one of the stars. You're going to figure out, is it arithmetic, geometric, or neither? You're going to color in the name box, and then that will tell you which box to go to next. When you're finished with that, let the sub know, turn it in for me, and tomorrow you're going to be working a little bit more with geometric sequences on an assignment. So we'll see you guys later. Sorry about that. Got a little confused there. Okay, we're back on track though. So your first set of rabbits was 2, and then you had 4, and then you had 8, 16, 32, and you continued and kept going. So I hope you noticed the pattern was happening. So each time we were multiplying by 2 by the previous set. So this is different than arithmetic because arithmetic is adding, geometric is multiplying. So that's really important to note. Arithmetic equals adding or subtracting. Geometric is either multiplying or, guess what, dividing, or fractions. Fractions are dividing, same thing. So let's talk about these examples. We're going to decide whether or not these are geometric, arithmetic, or neither. So I'm going to have you pause after I introduce each one. Go ahead and work it out, see if you can figure out which one you think it is, and then come back and we'll talk about it. So our first one is 525, 125. Go ahead and pause, think about it for a second, come back when you're ready. So we're multiplying by 5 each time here. And it is constant, it's the same every time, so this has to be geometric. The second one, we have a difference of 5 here and a difference of 5 here. There's nothing that you're going to multiply times 1 that's going to be 6 and then 11, because 1 times 6 would be 6. Well, if you multiply 6 again, you're talking about 36. It's way too small. So we know that this is an addition one. It is constant. It's adding 5 every time. So this is arithmetic. The third one, we have 1/2, 1/4, 1/16. Well, if we add 1/2 and 1/2, we don't get 1/4. If we subtract 1/2 and 1/4, we could get 1/4, but then if we subtract 1/4 again, we don't get that. We would get 0. So that didn't work out. So it can't be arithmetic. Let's try geometric. Is there something I can multiply? If I multiply this times 1/2, do I get 1/4? Yes. If I multiply 1/4 times 1/16, I get 1/4 times 1/2, sorry, I get 1/16. So therefore, this is multiplying by 1/2 each time. And this is geometric. Sorry, you were supposed to be pausing. I hope you knew we were doing that. So let's talk about the last one. So it looks like we're, go ahead and pause, work it out, see what you can come up with, come back. So we're starting at 4. We could do 4 minus 2, but if we did that, then 0 should be our next term. So we know it's not arithmetic. Let's try geometric. Well, if we divide 4 by 2, we get 2. But if we divide 2 by 2 again, we get 1, not -8. So it's not constant. Neither one of them work here. So this one is neither. It is neither arithmetic or geometric. Neither one of them work.